So, like the other hypothesis tests, I'm going to give an overview as to when we may use a hypothesis test of one mean, but this time the population standard deviation is going to be unknown. All right. This is actually one of the most useful tests that we're going to be looking at all semester. Standard deviation of the population unknown generally means that we just have a list of data and we compute the mean, we compute the standard deviation, and we want to test it against the population. All right, so let's say, for instance, let's say that we know that the population mean GPA of all Harvard Community College students is 2.63. Right. In other examples, we may have been told that the population standard deviation may be something like 0.39. Well, in this problem, because the population standard deviation is unknown, we can't be told that. All right. Let's say, for instance, I want to go out and I want to collect 10 samples. Okay, so I collect 10 samples. And let's say they're GPAs from our honors class. So maybe something like 3.73, and then 4.0, and then 3.20, 3.5, 3.5, let's say 3.9, let's say 4, let's say 3.33, let's say 3.40, and then finally, let's say something like 3.40 again. All right. Obviously, the average is going to be different, okay? But, so what we would have to do is we would have to compute the sample mean from the given set of data, and then we'd also have to compute the sample standard deviation from this set of data. So that's how this differs from the other problems that we've looked at. We're given a population mean, but this time, instead of being given a sample mean as well as the population standard deviation, we're just going to be given some random samples, and we're going to have to compute the average as well as the sample standard deviation of that. And I'll show you how to do that in a little bit. To be able to do this, we have to flip the method. Okay, so we're not going to be using the p-value method any longer. All right. The reason this is because unfortunately, when the population standard deviation is unknown, we cannot use the normal distribution anymore. Okay. Recall when we had the confidence intervals, remember we had to use t critical. So if you do not know the population standard deviation, you have to use t critical. All right. And I'm going to show you in a few moments how we're going to be able to get t critical. We're going to use a new method, and the new method is going to be called the critical value approach. Okay, so the critical value approach is used when sigma is unknown. Okay, there are ways to use it for when sigma is known. Okay, but I'm only going to show you the p-value method for that. Remember before we had the significance level. So we created the chart, the distribution, and remember we had the significance level. Well, now we're going to have the critical value is going to separate the reject and the failed to reject regions. Instead of a p-value now, we're going to get this thing called a test value. They're going to do the exact same thing. The test value is going to determine if we reject or fail to reject the null. The test value is not a p-value, it's not a probability. The test value is actually almost a z-score. It's the number of standard deviations from the mean or the center of the distribution. The critical value is again a number of standard deviations from the mean. All right, so it just basically computes how many deviations it would a value would need to be able to say that it is a rare occurrence as opposed to a probability. All right, so instead of us converting to a probability, we just convert to a number of standard deviations for the critical value instead of the significance. To be able to perform the test, we still have left tail, right tail, and two-tailed tests, but the difference is that the range of the distribution is now a t distribution. Okay, so these are all t distributions. The range of values on a t-distribution is negative to positive infinity. Okay, so in each of these pictures, the leftmost value is negative infinity, the rightmost value is positive infinity. All right, so up here, that's negative infinity, and this is positive infinity. All right, and I'm going to walk you through this as we go through, and I'm going to do like one of those setups where we do all 5 of the steps in a few moments. Right. One thing to be aware of is that just like any other two-tailed test, we would have to split the significance level before finding the critical value. And the last thing I want to show you is I want to show you how to use the t-distribution to be able to find the critical values during one of these types of tests. So, pull out your t-distribution, okay? And what I'm going to do is I'm going to show you how to be able to find the t-critical. Now remember, if you haven't done this, make sure you write t somewhere on your distribution just to remind you that it is a t-distribution. And what I also want you to do is I want you to cross out this top line where it says two-tailed probability. All right, so we're going to get rid of this. We're not going to use it. Okay. All of the values up top are the alpha levels. Okay, so basically we have alpha value of 10%, 5%, 2.5%, 1%, and 0.5%. You may recall that to find t-critical is based on 2 things. Before it was based on the confidence level, and remember down here we had the confidence levels. Well, we're not going to use the confidence level. What we're going to do is we're going to use the alpha level. Or if it's a two-tailed test, we're going to use alpha over 2. The other thing that we're going to do to look up t-critical is we're going to find the degrees of freedom, which are n minus 1. Don't forget, if for some reason degrees of freedom are not on the distribution, okay, you always want to round down if df is not on the table. Okay, it's very unlikely that we're going to see that in these examples. However, we may see in real life. You may have to see those. Okay. All right. So in the next video, what I'm going to do is I'm going to do an outline of how you're going to go through this type of t-test, and then the videos thereafter are going to be 2 examples of being able to compute those.